So today I'll talk about CAP theorem and PACELC theorem. And basically I'll more focus on the PACELC theorem. Little bit I'll touch base upon the CAP theorem. So the PACELC theorem states whenever there is a partition in the system, you need to choose between availability and consistency. Now let's see the CAP theorem. CAP theorem says out of these three, which is consistency, availability, and no partition means partition tolerance, in out of these three we can choose two. Out of these we cannot have all the three at the same time in a system. When we talk about PACELC theorem, the first three letters are actually the same. If you see how it is spelled PACELC. So PAC is just reverse of CAP, right? So basically the first three letters states the same. So PACELC's theorem uh, says that whenever there is a partition in the system, you need to choose between this part, which is high availability, or you need to choose between with this consistency part. You can have one out of these. So now let's see the other side of this. When there is no partition in the system, means the system is working perfectly fine. There is no problem in the system. In that case, availability is not a question, right? Because when the system has no partition at all, then in that case, all the parts of the system are working perfectly fine. There is no communication failure in the system. So availability is a no question. There's no question of availability. But still, in that scenario also, we need to do a trade-off between low latency or high consistency. Means it could be, we could choose the system should be faster in response, means low latency, or we have high consistency. If we have high consistency, then we will have high latency as well. Okay, but if we choose low latency, then we have to suffer on the consistency. So it's like that. So these kind of a trade-off we need to make. Let's see some example. uh, the MongoDB, right? So MongoDB, how MongoDB architecturally behaves. So during a partition, MongoDB chooses availability over the consistency. Okay, when there is a partition, but in normal operation, which is the right side of this flowchart, it chooses consistency over the latency. So this is how MongoDB behaves. Now let's see another database, another basically NoSQL database, Cassandra. Cassandra, during a partition, it chooses availability. Okay, but if there is a no partition, means it's a normal operation, it prioritizes low latency. So that's how these systems are designed. So the key insights of PACELC theorem is that when there is no network partition, means the normal case, the distribution system still needs to make a trade-off between latency and consistency. This is something the original CAP theorem did not address. So that's why we have this uh, PACELC theorem, which is actually an extension of the CAP theorem for distributed systems. Thank you.